Hi, I'm Pat Kelly. Okay, and in this problem, they give us f of x equals 2x. They give us the closed interval 0 to 1. And we're supposed to prove that it is a probability density function. So we have to really check three things. We have to check that the function is continuous and non-negative, two things. And then also we have to check the integral. We have to check that the definite integral of the function over that interval does add up to 1. So we'll check each of those three things. And for the first two things that we're supposed to check, if the function is continuous and non-negative, I'd probably try to start with a graph, especially these functions that are pretty easy to graph. This function's just linear. So we have a graph of a function of 2x, if I'm going to graph that, has an intercept of 0, so I know I'm going through there, and a slope of 2, so go over 1 and up 2, and it's linear. We would just have this graph. Okay, so there's our function, and the interval that they give us is 0 to 1, so we're really only even interested from 0 to 1 of that part of the graph. So when we do the integral, we'll end up finding that area. So back to the three things we need to look for. Trying to show that this is a probability density function. Three things. Is it continuous? Well, that's kind of a slam dunk here with a linear function. It's continuous. Just draw the graph, didn't have to pick up my pencil at all. Second thing we had to check for was that the graph is non-negative. Again, between 0 and 1, you're only looking between 0 and 1. Is your function above the x-axis or maybe touching the x-axis? Trying to make sure that the function is non-negative. So just between 0 and 1, it's non-negative. So we do have continuous, we do have non-negative. A third thing to check then is that integral. It's really the heart of the problem for this type of problem. What we need is the integral from a to b of f of x dx. It must equal 1. So we're challenged with checking that. They give us the function, they give us the interval. We just have to do the mechanics of an integral and see if our answer is 1. So let's get into our work. For the specific function they give us, we're going to have the integral from 0 to 1. My lower limit of integration is the left bound of that closed interval. The upper limit of integration is the right bound of that closed interval. My function is 2x dx. And I don't know what that equals. I have to figure out what it equals. But if the answer is going to be yes to whether this is a probability density function, we're going to see if that integral equals 1. If it does, then the answer is yes. So it comes down to the nuts and bolts of doing an integral. So we have 2x dx, do the antiderivative. That's just going to be x squared. Okay, so the antiderivative of 2x is x squared, and we're going from 0 to 1 as a definite integral. Okay, just even real quickly with the antiderivative, if it's been a while and you're rusty, just to go backwards, to check yourself, go backwards if you took the derivative. The derivative of x squared is 2x. That's how that one you can do so quickly. Okay, now the definite integral then, we're going from 0 to 1. And that just means that we put in, this is now the fundamental theorem of calculus, you're putting in that upper limit of integration, the 1, putting it in for x. Subtract what happens when you put in the lower limit, which is the 0 squared. Arithmetic's not too bad in this one, so 1 squared, take away 0, well, that's 1. So what we needed was the integral to equal 1, and we have the specifics. Our integral does equal 1, so is this a probability density function? Yes, actually the directions were to show that it was. So we did check that it's continuous, it's not negative, and we confirm that the integral does equal 1. Just mentioned area. That's another thing you can check with the drawing in this case, since it is simple drawing, simple in the sense that it's a recognizable geometric shape. Just make sure that that area is 1. It's exactly the work that you do with the integral, but the area of a triangle, 1/2 base times height, you have your base of 1, your height of 2, and the area of the triangle then just 1/2. Base of 1, height of 2. which equals 1. Just a little bit more confirmation, I suppose, but a quick visual, too, that yes, this integral does end up equaling 1 because the area of that triangle is 1. All right, so we've shown that this function, f of x equals 2x over the closed interval 0 to 1, is indeed a probability density function. Hopefully that helped. Thanks.